Assalamualaikum students. Now we are having a bit knowledge regarding the dimension analysis and principle of homogeneity. Let's going to apply this very principle of homogeneity. If we are having a question like this, that if x equals to what? A plus b into t plus c into t square, where x is what? Distance traveled by an object. Find find dimensions of A, B, and C if x is distance in meter and t is the respective time. Now, applying principle of homogeneity, we know as these very terms are in addition, so I have to equate them separately to x, and every term should have the same dimensions as that of the x. Now, let us first see we're having x is having dimension of what? X is having dimension of length. So let us going to check out. We have to find out what are the dimensions A, B, and C. So we will first say the dimension for by principle of homogeneity. Then we should have x equals to A. We should have x equals to B into T, where T is the time and B is the constant. And we should have x equals to what? C into T square, where x again the distance, C is the constant, T is the time. So as x is distance, so dimensions of A are, so A equals to what? M0 L1 T0. It is having the dimension of this. These are the dimensions of A. M1. This is the dimension of A. A is having the dimension of x, and x is simple. The distance, that's M0 L1. Now, what should be the dimensions of B into T? Now again, this x is having dimension of what? In order to calculate the dimension of B from this very, we will get what? B equals to x over T. So x is having dimension of M0, L1, T0. And we're having for time, we're having dimension of M0, L0, T1. So once we will take the dimensions, it will be M0. For B, it will be M0. And for it will be L1, and it will be T minus 1. And now to calculate the dimension of C, we are having again C equals to what? X divided by T square. So instead of x, we will having these dimensions M0, L1, T0, as x is the distance is having the time of length, and T is having M0, L0, T2. Then we are having dimensions M0, L1, T minus 1. So separately we calculate the dimension for A, it is L1, for B it is L1 T minus 1, and for C it is L1 T minus 2. This is how we are going to find the dimensions of constants A, B, and C. Okay, now we are having another question. If speed of a body is given as v is equal to a plus bt plus c divided by d square plus e plus t, find dimensions of a, b, c, d, and e. So by principle of homogeneity, what we have to do, this v and this a, as v is the velocity, so a should have the dimensions of v. So here, by principle of homogeneity, a equals to what? V, so should have dimension of m0 l1 t minus 1 as its speed. So a is having dimensions of this l1 t minus 1. Now we will take here again, I will take now this very term v should separately by dimensionally it should be equal to what? B into t. Why I am equating them? Because we are having by principle of homogeneity, every term which are in addition or subtraction should have the same dimension as the term in LHS. If you are going to check it out here, this is time, this is E, this is D, then E should have the dimensions of time, D square should have dimensions of time, because we are having the addition of similar quantity, so time should be added to time. Okay, so now here, which implies we will get B equals to what? V over T. So V is M0 L1 T minus 1, and it is M0 L0 T1. So once I will take the dimension, so B should have the dimension of M0 L1, and it should be T minus 2. So we got the dimensions of what? We got the dimensions of B, we got the dimensions of A here. Now we will check the third equation. Before checking C, let us check first E. As they are in addition, E is addition to time, so E should have dimensions of time. So should have dimension of M0 L0 T1, or simply T, it should have dimension. And similarly we're having what here? We're having, as I'm saying, E equals to T. Here in the equation, E equals to T. So this is the addition between two similar quantities, because addition is going to go between two similar quantities. Subtraction is going to go between two similar quantities. So E equals to this, equals to M naught L naught T minus 1. Similarly, we should have the dimensions for what? D square. It should have the dimensions of time. So it should have dimension of M0 L0 T 1, but we have to calculate the dimension of T. So D equals to, just it will get a square root there, it will be M0 L0 T 1 by 2, or simply you can place it like this, T 1 by 2 are the dimensions for D, or here you can place it E is equal to T1 is the dimension for E. Now we will check the dimensions of C. Now we should have V equals to what? C by T. Why C by T? This is C, and this whole is having the dimension of time, because we are calculating dimension. So which implies we have to calculate dimension for C is equal to V into T. So which implies C equals to, for V it is L1 T minus 1, and for T it is again the time T1 T, and T it's leaving. C is having a dimension of L. So this is how we are going to calculate the dimensions of what? The dimensions of, these are the dimensions of C, these are the dimensions of D, these are the dimensions of E. So you have to go through many more questions like this. Let me give a couple of questions to you. In the given two questions, you have to calculate the dimension of A. Here is P, the pressure, A is the constant, V is the volume. Here is the V volume and B is the constant. You have to calculate the dimension of A and B here, and here you have to calculate the dimension of A, B and C, while T is the time and V is the velocity. A, B and C, these are constants. V is velocity, T is time, and in this way, this is called as van der Waals equation. You have to calculate the dimensions A and B, where P is the pressure, V is the volume, R is the gas constant, and T is the temperature. You have to calculate what? You have to calculate the dimension of simply B and A. Hope you will go through it. Tomorrow will be another lecture, and then Allah Hafiz.